In this session, I'll give a live demonstration on internal incompressible CFD analysis of Nozzle by using SimScale software. To open SimScale software, go to browser or Microsoft Edge and enter the web address simscale.com. Next, go to Dashboard, create new project, give the project title, describe your project and choose the category. I'll give the project title as Nozzle and description will be internal CFD analysis. Choose category as aerospace. Click on create project. This is the interface of SimScale software. First, to import geometry, click on the plus icon in geometry. Click on import from computer. Choose your geometry file and click on import. The nozzle geometry is imported. In this problem, the air flows through the nozzle. The walls of the nozzle form its domain, which means there is no need to create domain for this problem. This completes the pre-processing step. Next, we'll start the second step, that is solver execution step, by creating simulation. To create simulation, click on the plus icon, select incompressible and click on create simulation. I'll keep the same K omega SST model in turbulence model and the time dependency will be the steady state. Save it. Next, assign material. To assign material, click on the plus icon in materials. Select air. Apply. I'll give the density as 1.225 kg per meter cube. Save it. Next, initial conditions. I'll keep the same default values. Next, we'll be assigning the boundary conditions. Select pressure inlet. I'll give the total gauge pressure as 3 e power 5. Select the inlet phase. This is my inlet phase and save it. Next, apply pressure outlet. I'll keep the 0 gauge pressure. Select the outlet phase and save it. In advanced concepts, numerics, I'll keep the same default values. In simulation control, I'll keep the same values. Save it. The next step is mesh. To create mesh, click on mesh. I'll keep the same values here. And to generate mesh, click on generate. The mesh generation step is completed. You can see the mesh generated on the nozzle geometry. After the mesh generation step is completed, the final step is to run the simulation. Before running the simulation, just ensure that in the navigation tree, you have a green tick on each node. If you have green tick on each node in the navigation tree, you can move to run the simulation. To run simulation, click on the plus icon in the simulation run. The simulation duration is 82 to 123 minutes. To start the simulation, click on the start button. The simulation is completed. This completes the solver execution step. The last step in analysis is post-processing step. In post-processing step, the results are analyzed which are generated after simulation. To start post-processing step, click on post-processing results. Here, select pressure. So this is the pressure counter plot of the nozzle. Next, add cutting plane. In cutting plane, select velocity magnitude. So orientation is Y. Right. Disable parts color. This is the velocity magnitude counter plot of the nozzle geometry. Disable cutting plane. Next, click on statistics. I'll select the inlet face. Here you can see the surface area, minimum and maximum pressure at the inlet face. Similarly, click on the outlet face. The surface area, minimum and maximum pressure at the outlet face. You can read it out here. Clear section. Go to parts color. Select velocity magnitude. Again follow the same procedure. Click on the inlet face. Here you can read out the surface area, minimum and maximum velocity magnitude, volumetric flow rate at the inlet section. Similarly, click on the outlet face. For the outlet face, again you can see the minimum maximum velocity magnitude, volumetric flow rate. In this way, you can see at the inlet and outlet what is the maximum and minimum pressure and velocity. This completes the analysis of nozzle. With this, I will end up this session here. Thank you.